Good day and welcome to another AAA webinar. I am Robert Sinclair Jr. I'm Senior Manager of Public Affairs for AAA Northeast. And if I look happy, it's because I am. We're going to talk about one of my favorite topics. I'm crazy about cars as it is, but I'm particularly crazy about tires. And government data says there are 276 million vehicles on the road. If you figure each of them has 4 tires, that means we're upwards of over 1.1 billion tires. And that doesn't include trucks and buses, which have more than one. So we know most passenger vehicles also have a spare tire. So there are a lot of tires in the US, and they are pretty remarkable. They are what connects the vehicle to the road. I remember reading in a magazine many years ago that the best car in the world is not any good unless it has the best tires. And when you consider that they have to endure weather, they hold the vehicle up, the heavy load of the vehicle, they pound over potholes, rocks, metal grates, dirt, and snow, all while holding air to add cushion and comfort, they are pretty remarkable. We tend to take them for granted until we get a flat or we need new ones. Joining us today to talk about these remarkable pieces of automotive technology is Tom Carter, who is a tire engineer with Michelin. Tom, thanks very much for joining us today.
Thank you.
You're welcome. Now, you went to Virginia Tech, whose nickname is the Hokies, but there's going to be nothing hokey about your presentation today. You got a mechanical engineering undergraduate degree and graduate degrees. How soon after graduation did you start working in the tire business, and why tires?
Well, I worked for General Electric for a while, and then I moved to Michelin, and so really about a year after graduating. And tires, because I was very attracted to Michelin, who takes a very synthetic and scientific approach to their work. And so that's what they recruited me, and I joined them 38 years ago, and glad I did.
And you have a momentous event coming up as far as your work with Michelin is concerned, correct?
That's correct.
You're going to be retiring, and we thank you for joining us with one of your last events, I guess. You worked in Europe designing tires. What was that like? And you were responsible for a pretty popular European tire. Can you tell us about that, please?
So yes, I did work in Europe and worked 4 years all the way back in 1992. That was before the European Union. So the French were not fond of speaking English, so I worked entirely in French. The French are very analytical, so that was a very good complement to my more practical background as an American engineer we're very practical and very experimentally oriented. They are very theoretical and mathematically oriented. So that was a very good learning experience for me to see their approach to engineering and combine it with more the American traditional approach to engineering. So I did design tires. I designed passenger car tires, and then light truck tires, and then 4x4 tires in Europe.
You know, in graduate school and studying cultural influences on products, they talked about just those sort of things, how the Japanese, because they have small living spaces, their air conditioners tend to be quieter because they're probably sleeping closer to them. And the Germans are very analytical and process oriented, and that's why they're good at producing chemicals. And the French have their own cultural influences, made them good at producing tires. It's interesting to hear. You speak French fluently, I guess.
Oui, je parle français.
Oh, très bien. I remember in French class in high school, there was a repeating phrase my teacher always used to say to me: "Fermez la grande bouche." We'll let everybody figure out what that means. Well, many have no idea about how a tire is made, and you've got a fascinating video on just that topic. We're going to get our technical man, Mark Shildrop, to roll the tire making video and pay close attention. There'll be a quiz afterwards. It's a very interesting video.
A tire is a complex assembly of many elements, implementing a wide variety of raw materials. The composition of the rubber compounds varies within a single tire. Each compound is carefully developed to meet the requirements in terms of flexibility, resistance, grip, etc. Long lengths of metal and synthetic cable are also used. Manufacture is performed on the drum, a rotating cylinder whose central flexible section can be inflated for reasons which we will see later. The first element applied to the drum is a sheet of airtight synthetic rubber. This layer replaces the inner tube in today's tires. In a second stage, a ply made of textile cords, sheathed in rubber, is then added. This network of cables will form a reinforcement radiating around the tire. It is the radial carcass. Braced against strips of profiled rubber, two high-resistance metal cable hoops are installed. These are the bead wires. They will hold the tire on the rim. The casing ply is folded over the beads to anchor it. Other elements are added. The sidewalls made of flexible, resistant rubber will protect the tire from lateral damage. The tire is then shaped by inflating the central section of the drum. Two plies are applied to the crown of the tire. They are reinforced with metal wire arranged obliquely and, with the casing ply, form a network of triangles to limit the deformations of the tire. Finally, the tread is fitted, the part of the tire in contact with the ground. The tire blank can then be installed in the curing mold. In the center, a bladder filled with pressurized hot water pushes the still malleable material to the base of the patterns engraved in the mold. The heat of the water and steam surrounding the mold will cause curing to begin. The rise in temperature causes vulcanization of the rubber. The sulfur incorporated into the rubber compounds forms bonds between the polymer chains. At this point, the rubber switches from a plastic state to an elastic state. When removed from the mold, the tire has acquired its definitive form and properties.
Fascinating. So I take it from that video, tires are largely handmade. Is that accurate?
No, that video shows the process, which is handmade, but they're largely made through automation at this point in time.
I guess that makes for better quality control.
It does, yes.
It mentioned textile cords and a radial carcass. Now, I remember back in 1980, I bought a 66 Chevelle with bias ply tires. And soon thereafter, I put a set of radial tires on. And I guess that carcass then is what gives a radial tire the radial designation. What's the difference between bias ply? If we had seen a bias ply being applied there, what would be the difference between the radial ply?
In that video, you saw the radial cords, which are radial coming out from the tread. And of course, a bias would be a carcass that's crossed. So it'd be two plies that's crossed, and that would be a bias ply tire.
Why are radial tires? My vehicle after that was smoother, it cornered better, it steered better. Why are radial tires better than bias ply for those characteristics?
The main reason is because of the flexibility in the sidewall. So with the radial tire, you don't have to overcome the resistance of two plies being crossed. So you only have a single ply that's not crossed, and that allows you to have lower rolling resistance or better gas mileage, but also a smoother and more comfortable ride.
And I know a buddy of mine had a pickup truck with a giant Lincoln arc welding machine on the back, and he had tires that had 10 ply, and this tire had 2. So those extra plies give greater strength and durability?
Correct.
Very good. Okay, well, I understand that you have a presentation, Tire Technology 101, everything that a consumer needs when they're going to buy tires. And why don't you hold forth with your presentation? I know there's a lot of information in it. And,
All right, go ahead and click, Mark. And we are actually not going to go through these 137 slides. We're going to do something a little more practical, and then a little bit more fits with the time constraints.
We only have an hour.
Next slide. Click. So we're going to give an overview. We're going to tell you, okay, how do you replace your tires on your vehicle? And the reason we're going to do this is you'll see, okay, I need to replace my tires. What do I need to know about? And then I'm going to talk to you about some of the advances. Go ahead and click some of the advances, and go ahead and run the video. Some of the advances which will be very interesting to you.
Okay.
I'm Tom from Michelin with my friend the Michelin Man. Today we're going to learn about what gives a tire good traction. It's easy to look at the tread pattern and think that's what does all the work. But in fact, a lot of the real magic is in the tread compound. I have with me 3 smooth hockey pucks. The only difference between them is this one is made out of a summer tread compound. This one is made out of a typical all-season tread compound, and this last one is made out of a winter tread compound. Let's see how far they slide on the ice. Go ahead, Michelin Man, give them a push. So what we just learned? The tread compound with the most traction stopped first, just like the tires on your car. The winter compound stopped first on the ice, followed by the all-season compound, and the summer compound slid the farthest, showing you once again why you don't want to drive summer tires in winter conditions. Michelin designs the tread pattern and the tread compound to help you stop better. Be safe, drive on good tires. Thank you.
Michelin, a better way forward.
Well, you know, Tom, I'm a hockey fan, and my favorite team is the Rangers, and I think they must be using the winter pucks because their shots seem not to be going as far and as fast as everybody else is using a summer puck. But that was very illustrative of the different compounds. Why does that happen? How does something rubber on sheer ice vary so greatly in its traction?
Well, the rubbers are adapted to be adherent to the surface, and they're largely dependent on temperature, and that's based on something called the glass transition temperature, which is the temperature at which the rubber goes from a rubbery state to a glassy state. So when you design a tire, you need to manage that very carefully so that the tire is adapted for its environment. So
I'm sorry, go ahead.
Let's go ahead, and then let's see if we can get through. Otherwise, we're going to really run out of time.
Okay. All right. I was just going to ask what sort of things might be done to the compound to change the traction. Is it all chemical based? It's what you put in the compound when it's still malleable, as they said in the video?
It's the types of polymers that you use, you know, so there's polystyrene, and there's butadiene. So it's the types of polymers that you use, and then it's the additives that you use, and then it's how you cross-link. So it's a combination of a number of things. So cross-linking, of course, has to do with how you cure them.
And polymers are long chain molecules. They're big molecules.
Exactly.
Okay.
So
please continue.
Okay, so a couple things here. You know, tires are different and adapted to the season. The compounds play a huge role in the performance, and you can't judge a book by its cover. You really need to test tires in order to find out what's going on. Go ahead, click, Mark. So if you're going to get a tire, you're probably going to get it for not a swing. Click. You're going to get it for your car, more than likely, or someone else's car. So it needs to match with the fit and the function. Go ahead and click. And so the fit's pretty easy. It's the size, 245 40 R18 in this particular case. Click twice and then a third time. And so then you have the diameter and the width that you're dealing with, and that's taken care of in that size. Now you've got the function, and the function in its basic form is the load that you need to carry and the speed at which you're going to travel. Click again. Now click it one more time. And so what you've got, very simply, that's been worked out over the years, is you have a size designation, like the 245/40. In this case, it says ZR18. And what we call a service description, which you have a number 97, which is the load index, which tells you the load that that tire can carry. And then you have a letter, which is a speed index.
What's the maximum load number that you could have?
I don't know off the top of my head, but I would say for a passenger car tire, it's about 110. Then we start moving to what we call light truck.
Right. So this is a pretty high load tire. It will hold up a lot of weight.
It's pretty high. That's correct.
And that Y designation means that it's good for sustained or up to 186 miles per hour. Is that correct?
That's correct. I think of it in 270 kilometers per hour.
Kilometers per hour.
Yeah.
See, all that work in Europe you did, you got you used to kilometers per hour.
Yeah.
That's a pretty high speed tire. That'll get the mail delivered on time.
Yep. Sure will.
Yeah.
And then click again. Now these things will be on the sidewall of the tire. So that 205 is the width of the tread. 55 is the aspect ratio. That's the ratio between the width of the tread and the height of the sidewall. And then 16 is the rim diameter. And of course, 89 is your load index. And S is a much lower speed rating than the Y that we just saw. So that's click. Go ahead.
I was just going to ask the 55 number, because I think that's probably the most confusing part of tires. That's a percentage of the height to the width. Is that correct?
That's correct.
So the tire is, that 55 is 55% as tall as it is wide.
That's correct.
If it's 205 and 205 is in millimeters, that's how wide the tire is. So the height of the tire is roughly around 50 millimeters, something like that, with the 55 aspect.
Roughly 100 millimeters.
Excuse me, half. Yes, 100 millimeters.
Right.
So I have a calculator. Yes, please continue.
Okay. So then Robert asked about these Utqg markings, and that's a really good question. The tread wear is an indicator, but it's a poor indicator. It's a relative indicator of how well your tire is going to wear. A much better indicator is the actual mileage warranty, which comes on most tires in the United States. The traction rating is a horrible representation. So the USTMA, United States Tire Manufacturer Association, has petitioned the government to remove this because it's a 40-year-old regulation. And of course, cars have advanced quite a bit in 40 years. Notably, every car on the road or every car sold has automatic traction control, or ADS. So this regulation is based on locked wheel, but every car on the road now stops based on automatic traction control.
Yeah,
so not locked wheel. So it ends up being a very poor representation of traction. And you would think, well, wouldn't locked wheel and peak traction be related? In fact, they're not. And Consumer Reports confirm that for us. And they joined the petition by the Tire Manufacturers Association saying we need to remove this because it's misleading to the consumer. The
That
next,
traction rating is what they have lobbied to get rid of.
that's right.
Okay. Tread
So-
wear, they still want to keep, but you say it's not as good as the tire's mileage warranty as an indicator of how far it'll go?
If I were advising any friend of mine, I'd say, I think you're better off looking at the warranty rather than tread wear.
Okay.
And then temperature is a relative rating, which is misleading. It's really related to the speed rating. And once again, the actual speed rating on your tire is a better indication than the temperature rating on the tire. So you know, when these regulations get made 40 years ago, the government is not so fast at reacting as private industry is. And so private industries really had to move off of things. Now, the government was very good about safety. And that's part of the reason we have ABS on all the vehicles sold now. But some of these other regulations have lagged behind. So that's the other thing that with the Tread Act, they've been good about safety for tires. And virtually all the passenger car tires are pretty good on the temperature now because of the Tread Act, which really makes us put a nylon ply on our tires so that they're less susceptible to rapid air loss.
So for years, I've been using speed rating as an indicator of a good tire. I figure if it's safe at 150 miles per hour, which my car would never achieve, it would be infinitely safer at 55 miles per hour. Is that accurate?
Some respects it is, in some respects it's not.
Okay.
The temperature rating is, again, or the speed rating is a test done on a drum for the tire, and the tire has to sustain a certain speed for a certain length of time. So any tire that can sustain a certain speed, a certain length of time, the higher the speed, in general, that tire is a little bit more robust than a tire at a lower speed rate. So you're entirely correct in that regard. In terms of safety, though, that's not the only element of safety.
Okay.
There's traction, there's handling, there's stopping. So it's probably safer for endurance, but maybe not safer for other aspects.
What would give a tire a better speed rating, its ability to endure that higher speed for a greater length of time?
Typically, that's done with the cap ply, which is a nylon ply that's applied over the belts in the summit area.
Okay. Which we saw during manufacturing. Okay.
The next slide. So when you go to replace tires, as Robert just indicated, you've got a whole range that you can go look at. And this is a Michelin Portfolio, and not to highlight Michelin, to say that most tire manufacturers have a portfolio similar, where they have tires that are pretty much max handling and work well in the summertime or 3 seasons. And then they have a winter tire, which works really well in the winter, but really not well at all in the summer. And then the vast majority of tires are somewhere in the middle there. Next slide. So what do you have mainly on the road? Well, if you look and you say, okay, now what tire am I going to get? And it's a little hard to see, but this is a typical retailer. They have touring, they have performance, they have winter, they have truck and competition. The brand's easy, that's Michelin. But when you want to get the other categories, that's a little more difficult. So click again for me. So all season tires are 85% of the market in North America. Next, click 2 more times. Summer tires, that's really in North America, that's a specialty tire. Corvette, Tesla has some summer tires. Some of your higher end BMW fitments come with summer tires. Winter tires, I don't know of any vehicles that actually come with winter tires, sometimes called snow tires. People do run snow tires, but it's mainly in the north of the United States. The next click again, I'm going to teach you a little bit about an all-weather tire. It's quite interesting. It'll give you an idea of tire design. It'll give you an idea of how you might want to go in your choice of tires. So an all-weather tire, click again. See where, oh, that's just showing you in the summer tire lineup. Could be a whole range that you can look at. Click again. So here we see, if you look on the right, the category all season. Again, the most popular tires in the United States and Canada. They do not have a severe snow rating like winter tires do. They do have an M+S rating, and they do have that UTQG rating, which really tells you it's suitable for the North American roads, all seasons. Summer tires have the UTQG rating, but they don't have the M&S, which means they're good, but not in the winter time. And of course, they do not have a winter rating. Winter tires have a winter rating, they have an M&S rating, but they don't have UTQG, which means you really should not be running your winter tires in the middle of summer.
What would happen if I did?
You would lose wet stopping distance. Okay, so back to your safety. In my opinion, a winter tire used in the summer is not a very safe situation.
Okay.
Because your wet stopping distances would typically be poor. You're
That's
likely
because of the temperatures that it's being used at?
The compound to the tread on that winter tire is not well adapted for summer temperatures.
Understood. Okay.
So now we get into an all-weather tire, and there are really two types of all-weather tires. First of all, it does have UTQG, it does have M+S, and it is rated for severe snow, which is quite interesting, which means you can use it in Quebec in the wintertime when they require you to have a tire with a severe snow rating. Now, this is a certification. This is not just a designation. It's a certification. In order for us to mark our tire, we have to test it in snow per the STM test, and we have to meet that traction rating. So it's interesting. So let's look at that a little bit. How do we get there? How do we get there safely? Well, with normal tire design, if you were designing a summer tire, you would have a hard rubber, and you would have that rubber with a very high glass transition temperature. Okay, if you don't understand that, that's okay. Just know it's a hard rubber. Now that summer tread pattern would typically be with very few cuts, very few grooves. The ultimate summer tread pattern is a Formula One tire or a NASCAR tire, which is completely slick.
Yeah.
Okay. So that gives you great traction, not so good on wet if it's completely slick, but summer tires are quite good in wet, and they're quite good in dry, and quite good in the summer. Now let's move to the other side of the ledger and look at a winter tire, and you see that winter tire is going to have soft rubber or low glass transition temperatures. It's going to have lots and lots of grooves and lots of sipes, lots of small cuts which bite into the snow and give you good grip on the snow. Okay? All right, next, click again, Mark. Now an all-season tire is in between. Click again. And we've made these all-season tires, invented by Goodyear and brought to the North American market. And we've made these for 30 years now. And it's been more or less a combination. The tread pattern is somewhere in between, the tread rubber is somewhere in between, and we've made very good all-season tires, and Michelin sells a lot of these very good all-season tires to date. But now we've learned something new in the industry. Click again. Now, we're going to go to vehicles here, because I know a lot of you AAA guys know vehicles. And I've got a curve on here, and it's engine power. And the blue is increased engine power by increasing the cylinder size. So a 2-liter, 3-liter, 4-liter, 5-liter Mustang. Or adding turbo. Now in the past, when Robert had his Chevelle and he wanted to increase power, he didn't drop a new engine in there. He either turbocharged or supercharged that engine. So click there for me, Mark. Let's see if it is. So He wanted more power, he put a turbocharger on. That worked great. Well, the problem with that is, click again, is his gas mileage. His gas mileage went down after that. It got power, but it went down. Now, some of you are old enough to remember the 80s when we really had a gas crunch. We didn't just have gas go up in price. We had gas disappear from the pumps, which is a very different dynamic than what most people now know. All right, click again. So if you want that mileage, what do? But you want to keep power. So this is what the manufacturers have realized. They've realized what we're going to do is we're going to reduce the cylinder size, click again, and we're going to add turbo. So my Audi A4 has a 2-liter engine, which is minuscule compared to the Chevelle that Robert had. However, it has 252 horsepower, which is more than Robert had with his 4-liter engine or thereabouts.
Yeah.
And so how is that? Well, it's because we got this turbo. But what's beautiful about this turbo is we've got power and we have gas mileage. And that's real engineering. It's not compromising. It's figuring out how to do things differently so that you can get to a new point on the curve. So Michelin did some real engineering, and I say Michelin because I know that that's what we did because I was part of it. Click again for me, Mark. So what we did is we said, okay, look, if we're going to design a winter tire up there, that snowflake, what we're going to do is we're going to grab a winter compound, we're going to grab a winter tread pattern, and that tire is going to be fantastic in snow. But it will stink in dry traction and notably wet traction. Now on the other end of the curve, down the lower right-hand corner, if I want to make a really good summer tire, I'm going to follow that blue curve down, I'm going to follow that green curve down, and I'm going to put together a summer tire, and it is going to be great in dry and wet in the summertime. But it will suck in snow traction, pardon the vernacular.
Technical term.
So much so that we tell people, and every tire manufacturer tells people, do not drive a summer tire in snow, and certainly do not drive it in temperatures that are freezing. You will void the warranty on your tire if you do that. So typically what we've done is we've designed a tire to be right there in the center there, that crossing point. Well, that works pretty well. It gives us some pretty good snow traction. It gives us some pretty good dry traction, but not that good. And what we realized, just like the people putting turbo on, and I'm not going to show you our proprietary slide, but you see where there's that graph is kind of blanked out. We realized by doing a little bit of a trick, we could be in a significantly different place on that curve. And the way we did this was we rode the green curve, which was the compound curve, up, and then we rode the tread pattern curve in the opposite direction. And that put us, if you want to look at it, at the coordinates, well, back one, that put us sort of in the center of that curve, or just a little bit higher, which meant we had really good snow traction and we had very good dry traction. So this was a revelation. Now, what does that mean practically in design the tire? Click again. So we took our summer, click again, and our winter, and we didn't meet in the middle like our typical all-season tire. We crossed. We took, click again, summer compound, and we took a summer tread pattern,
Right.
and a winter compound, and we crossed the two. And when we did that, we got something very, very interesting. We actually did it the opposite direction, and it doesn't work so well. We got something very interesting. we got something that worked very well in the summertime, that is on wet and dry, but also gave us very good snow traction. In fact, the snow traction of that tread pattern shown there, which is pretty close to a summer tread pattern, is capable of receiving the severe snow traction certification, because that compound is so well adapted to winter conditions. Now, we had a major problem when we did that, and that was that compound under very severe conditions was not robust. So we had to figure out a way to make it robust, and we did, and I'm not going to tell you how we did that, but we did that. And so now we have, click again, let's see where we are. We have a breakthrough tire, and this tire is the Cross Climate 2. Now the competition is going to follow us. They're going to figure out what we did. So the industry is going to have a breakthrough tire, and that breakthrough tire is not going to be like some of the all-weather tires out there now, which are just snow tires, in which case they said it's okay to run in the summertime, which is not good. It's going to be a tire that really works well in all seasons. And you don't have to take my word for it. Let me show you this, okay? Click again. So Consumer Reports, who I cannot reproduce their material here without paying a lot of material. So you can go to Consumer Reports and you can look and see they rated 26 models. Now these models were just all season tires. They were not winter tires. They were not all weather tires. They were the most popular tires in North America, all season tires. And when they did that, click again. At the top was the Cross Climate 2, the best performance all season tire in the country. So you live in Dallas, you don't care a thing about snow, but you want the best all season tire, you buy that tire there, which is also certified. All the tires, which you cannot see with little arrows, were certified for snow. There was one tire that made just barely the top 5 that was certified for snow. The 2 at the bottom were certified for snow, all weather tires, and they were number 24 and number 26 in Consumer Reports evaluation. And why? Because their wet traction was horrible. So you need to be a little bit careful if you choose this category, because there are people that have made real advances. And I'd say there are 3 manufacturers that have done that. And then there are other manufacturers who have not. And so it's very interesting, because there's probably not a one of you in the room that has a desktop computer. And why is that? Because laptop computers have made all the progress in the world, and they fit our lifestyle much better. I think that's going to be true of tires. The winter tires in North America are really not going to be very pertinent, because you can choose an all-weather tire and get the snow performance that you need. If it's dangerous outside, we do like we do now, we work from home. The vehicles are much better for snow now. Why is that? Front wheel drive, all-wheel drive, dynamic stability control, traction control, and also better weight distributions.
I have a question.
Fire away.
There's a lot of information. And so if 85% of us have all season tires, they are a compromise, but not as much of a compromise, is what you're saying, compared to that dedicated summer tire or that dedicated winter tire. By the way, I think the people in Dallas this past week would have appreciated some snow performance.
See, now if they bought the #1 performance tire, they would have had #1 performance all season tire. They would have had a tire certified in snow, cross climate. It would have really helped them out.
Now, so I remember, boy, when did this car come out? The Honda S2000. Many years ago, when I wrote the test drives for our magazine, I was testing that vehicle in November. November can be kind of changeable. November, one day it can be upwards of 60 or 70, and another day it can be 30 or 40. And that's what happened. I had been driving the Honda S2000, which was a real nice car, rev happy engine. I think it revved to 9 or 10,000 RPM. And parked in a garage, went into Manhattan to do some business, came back to the garage in Long Island City. The temperature had dropped, came out of the garage, made a turn on Vernon Boulevard, and the car spun around. Had summer tires. So I was experiencing that effect that you're talking about, where the low temperatures, in essence, can turn that material in that summer tire into like hard plastic.
Right.
And that's why I lost traction. So I went to work the next day and talked to my coworker, Louis Orellana, a fellow car nut, and I'm like, this lousy car spun around on me last night. And he's like, no, Rob, summer tires. That thing has summer tires, and that's what happened. So we are not then in a compromised situation if we're using all season radials throughout the year.
If you put the cross climate on there, you can compare that to some summer tires. Now, it is, if you ask me as a designer to design an all-out summer tire, I can beat the cross climate. But that being said, that tire is very, very good in traction and handling, in wet and dry. In fact, it's the only tire in the history of Consumer Reports to receive a green top rating in snow, dry, and wet. So it is compromised compared to an all-out summer tire, but not very much.
If you see a spike in sales for that tire in New York, I think you'll know why.
You'll know why. And,
Yes.
and guess what? Those customers will be happy. They'll
Very
be very
good.
happy. So it's just like I have in front of me a Dell laptop. Someone else has an HP laptop. Someone else has an Apple laptop. Those advances in laptops are in all brands. It hasn't happened yet. It'll be 3 years. But the advances that we're talking about will happen in the major brands. But again, it hasn't happened yet. And why? Again, we do make advances in engineering. It is not, the car that you buy today has tremendous horsepower and tremendous gas mileage. It's not, okay, well, we totally sacrificed horsepower and now we have only gas mileage. So in the tire industry, we're working to make real advances, and fortunately we have.
What is the most important thing that a driver should do to take proper care of their tires? They've got their funky new all-season radials. They want them to last a long time. They want them to be at optimum performance no matter what time of year it is. What should they be doing?
Good question. Really, you should keep your tires inflated to the proper pressure, which is the pressure on the placard, which is inside the driver's side door jamb, which will tell you exactly what pressure you should keep. Exactly.
And I have a couple of tire gauges here, and it might get a little inconvenient during the winter time. Isn't it true that tires lose pressure as a result of the outside air temperature? And what should drivers do for that?
It's exactly right. You know, there's confusion. They don't lose air, but they do lose pressure.
They lose pressure.
That's the ideal gas law. So they lose pressure because the temperature drops, and so you need to add air to your tire.
Heat expands, cold contracts, and that's why that happens.
Exactly.
What about tire rotation? And to me, that's a misapplication of terms because tires always rotate. So what is tire rotation and why do you need to do it?
So most vehicles do not wear evenly front axle to rear axle. And most of the time the differential is front to rear. There can be slight differences left to right. The best rotation is front to rear. And and vice versa. Yeah, front to rear, rear to front.
So in
Just
essence,
a
we're talking about
straight-
swapping.
Just a straight rotation. Take
Okay.
the fronts and move them to the rear. Take the rears and move them to the front. Keep the same side of the vehicle. Okay.
How often should that be done?
About every 5,000 to 6,000 miles. Now, yeah, that's a lot.
Yeah.
So if you have, unofficial speaking here, not Michelin speak, but you can look at your vehicle and you can determine, like my Audi, all-wheel drive Audi, I do not need to rotate my tires that often.
Why is that? Does it have
Because
to do
I
with the
have
all-wheel
torque.
drive?
Yeah, that's it. I have torque in all 4 positions. The torque wears the tires. And since I have it in all 4 positions, that vehicle wears tires pretty evenly.
No, I thought it would be the weight. If you had a rear-wheel drive vehicle, I thought you would wear out the fronts because most of the weight, if it's a front-engine rear-wheel drive vehicle, I mean, you're holding up most of the weight of the car, you're steering the car. When you brake, the front end dives, the vehicle dives, so you got more braking force. I thought those would put more extra wear on a tire, but you're saying it's the torque, so I guess the rears would wear more quickly.
Typically the rears would, but you're correct. You're exactly right, Robert. The tires will wear more quickly because of those things that you said, because of the weight, because of the braking torque. However, anyone who's owned a BMW knows that the rear tires always wear out quicker than the front tires.
Well, if you had a Mustang, you like to spin the tires, they're going to wear out more quickly. Now, I had the experience of driving very briefly a BMW electric vehicle, the i3.
Okay.
And very interesting to look at that placard on the inside of the door jamb where it gives the correct tire pressure. And if I remember correctly, for that vehicle, it was 45 PSI. And on my truck tire, it's 31 or 32. Why did that electric vehicle have tires that required such high pressure?
Range.
Range.
Okay, so why is that? So that's the one word answer. So that the higher the inflation pressure in general, the less tires deflect. The less a tire deflects, the less energy it uses in rolling. The less energy it uses in rolling, the less electricity it drains from the battery, the better the range on that electric vehicle. So electric vehicles are very sensitive to the rolling resistance of tires. So is that truck that you had, for example, but they're very interested in comfort. They're interested in traction and handling on the road. So they want a tire that's adapted to a lower pressure, mainly for absorbing bumps and comfort.
Do I harm my tires myself, the tire's performance, by adding some extra air? I like to put in an extra 2 or 3 pounds to save me having to go out there and pump them up when it gets colder. But I think does it keep this? I've heard that it keeps the sidewall stiffer, so it give you slightly better handling. Am I doing the right thing, or should I not do that?
That's a personal practice of mine. So I would say yes. Now, the official regulation is inflate to the placard, but you're better off inflating to a 1 or 2 PSI above because things do drop over time. So that doesn't hurt. But then if you want a little bit stiffer ride, a little better handling, then that's a good idea to inflate a little bit. If you inflate, here's the risk. If you inflate too high, you will make the contact patch, the surface that touches the road, small, and that can give you a risk of wet traction. There you go. That can give you a risk of wet and dry traction. Now, hydroplaning is different, but it can give you a risk of wet and dry traction, and it can cause the tire to wear out in the center more easily. So you can have what's called center wear.
Right. So if I put too much air, the center portion of the tire is going to bulge out and wear more quickly. The opposite is true. If I'm underinflated, the center portion will go in and the edges will wear out more quickly. Isn't that right?
That's correct. Exactly correct.
Good. It's good to know I'm doing the right thing. Can't worn suspension components also do bad things to your tires?
Absolutely. So one is vehicles out of alignment can cause a problem. I will warn all of you out there, and I know they're AAA shop people, but my standard advice to people is do not get in alignment. Oh, wait a minute. Why did you say that?
Yes.
Why did I say that? Because if your tires are wearing properly, so much of modern cars now, the alignment is fixed. Caster and camber are often fixed.
Caster, camber.
Yep. Now toe is very, very rarely fixed. It can be fixed in the rear. But if your tires are wearing properly, you're probably just as well not having someone tweak the factory settings. That's my personal advice. It may go against a AAA because I know you do alignments, but my personal advice, if your tires are wearing well evenly all the way across, don't do alignment. If they're not wearing well, first do an alignment, and then if you have to have components replaced, replace those components.
Suppose I get a new set of tires. Should I have them have the wheels aligned?
My recommendation would be no. And that, again, if your tires are wearing well, I would not align my vehicle.
You know, it's interesting because I have a 2014 Subaru Impreza, and I was at a parking lot at a big box store, and I mistakenly drove over a curb. You know, those things, bollards they have at the end of parking spaces. I drove boom, 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 boom. All four tires went over. And I said, okay, that's it. I'm going to need an alignment. I'm going to need bushings. I'm going to need shocks. I took my vehicle to TNT Automotive, a AAA approved auto repair shop. They put it up on the lift. No problem, Robert. Everything's fine. And drove home.
Okay.
It was stunning. You know, I thought I would have done so much damage, and yet and still, testimony to the alignment, to the car, what have you, I didn't have to do it even after driving over a curb. So
I don't know that particular vehicle, but some of those things, when I say they're fixed, they're welded. Okay, your caster and camber are welded, fixed. You can't adjust them if you want to. So,
how do you know whether or not that's the case for your vehicle? How can you make that determination? I guess only your technician knows for sure.
You have to search on that. That's kind of advanced, and the owner's manual might say, but it probably wouldn't. But again, if your tires are wearing well, then I would stay away from alignment.
Very interesting.
Now, if they're not wearing well, I mean, it's like you say, you know, if you have no symptoms of COVID, don't necessarily go in for a COVID test. If you have symptoms of COVID, go in for a COVID test. So, you know, if you have symptoms of bad wear, get an alignment.
Okay. Well, we have a little bit of time remaining, and I'm going to be very selfish right now because I want to talk to you about a passion of mine, which is aircraft tires. Uncle of mine worked for Grumman Aerospace for 35 years, starting off when I measured my age in single digits. And so I've been around airplanes for a long time from early on and found them very fascinating. And we're not flying as much these days, but when you consider that a 747 weighs roughly 750,000 pounds, and it's got 18 tires, 2 in the nose wheel and all those at the back. If you watch a 747 coming in for landing, they've got bunches of tires on bogies under the middle of the airplane. That means each tire is holding up roughly 41,000 pounds, and even more when it lands, all that weight is crashing into those tires. What gives those aircraft tires the ability to carry so much weight, and especially on landing, and how are they differing differ from your vehicle tires on the street? They're
So you
big, that's
see
for
up on the
sure.
screen there an aircraft tire, and you see it's got 3 bead wires compared to a typical tire, which has 1 bead wire. It has, I can't count the plies, but let's say 10 plies, maybe
Okay.
12 plies, as opposed to 1 or 2 plies of a typical passenger car tires. Is very thick, very reinforced.
Hmm.
And then the pressure of that tire would be 10 times the pressure of your, no, 7 times the pressure of your passenger car tire. So it'd be like 200 PSI.
Wow.
So that's a very, very stiff, hard tire. It's stiff pneumatically, it's stiff structurally. So that stiffness enables it to withstand, as you said, that landing. The weight of the aircraft is nothing compared to the weight of it landing. Because when those things pop down, I mean, it's at least 10 times the load. The dynamic load is at least 10 times the load of the aircraft.
So we're talking 7 million pounds when that 750,000 pound.
Yes.
Yeah.
I have to do the math on that, but
Yeah.
yeah, you're talking a lot of force, Now it's a very short duration, but it's still a tremendous amount of force. And so these tires have to be extremely robust. Now the advantage is that they don't have to go very far. So you'd think, oh, a super robust tire could go a long, long ways. No, a super robust tire like that cannot go a long ways at high speeds. It would heat up and fly apart because of so much material in it, so much internal friction. I have that picture of that plane landing. People watch those planes land. They see all that smoke come off of the tires, and they think, well, geez, you ought to be able to prevent that. So they think of having the tires spin up to speed before you land.
They used to do that on World War II bombers, if I remember, that they had like vanes built into the side of the tires that would get them spinning. That was my next question. Does going from 0 to 160 miles an hour an instant like that do something to negatively affect the tires?
Not really.
No.
You would think it would.
Yeah.
It doesn't really. It doesn't really. Those tires hit that ground and they start spinning. It doesn't matter if they're spinning or not. It really doesn't have any effect. So that's,
very interesting. Now, are these tires radial
you'd
tires?
have vanes on all those tires, like the World War I or II bombers, whichever you said. I can't recall. But no, it wouldn't. It has very little effect.
Those are some tough tires. Now, do they have radial tires, or are these bias ply?
They're both. There are a good
both.
number that are radial and a good number that are bias.
So now an aircraft at high altitude, it's flying along at 28,000 feet. It might be, those tires are subject to extreme cold. I think it might get to 20 degrees, 30 degrees below zero when a plane is at altitude. Does anything have to be done to the tires to have them withstand those cold temperatures? And then, they're landing at Miami. All of a sudden, they're going from 20 below to, 95. Is there anything,
Yes,
are they still?
That is a design. You're exactly right, Robert. That's a design consideration, a design constraint. What allows that to happen is they do not have to be utilized at that very cold temperature. So that is very helpful. If you had to run those tires at that cold temperature, that'd be a really tough design problem.
But they've got airports in Alaska. There's a show I like to watch about an airport in Alaska. It might get to freezing, below freezing there. What about those circumstances?
Yeah, you got to design for that. You got to design. Your summer tires would not work there. They would crack and fall apart.
Now, I remember speaking to an engineer many years ago, and you and your coworker Phil have confirmed that many many aircraft tires, those big, robust aircraft tires that we see, are retreads. And in fact,
Right.
aircraft tires can be retreaded, if that's the right term, multiple times. What is a retread? Now, I see carcasses of tires by the side of the highway all the time, and I remember being told those are retreads. So I don't know if I'd like a retread on my aircraft tire. What's the difference between these retreads that I've seen from car tires and retreads on aircraft tires?
Yeah, there's a very big difference. Click back one, Mark, if you can. So you see that the tread on those aircraft tires is really a very small part of that tire.
Mm-hmm.
And so airports are very clean, relatively speaking. There's no nails, there are no roofers, there's not any shrapnel, there's not any bumper parts, muffler parts. There is nothing on
You've
an
been to New York.
even LaGuardia, they clean that up in a heartbeat.
Yeah, until you get off the runway.
Yeah, they cannot afford to have a tire fail either on the ground or in the air.
Mm.
And in fact, in the air, a tire is considered a pressurized vessel. And so in the belly of that airplane, they have shrapnel cages. So if one of those tires does blow, it does not send shrapnel through the aircraft, either damaging the integrity of the aircraft or a passenger. So they have to be very careful about that. Now, that being said, they still inspect those tires very, very carefully before they put a retread on there. That is the practice in the industry for truck retreads, to inspect very carefully. But it's a large number of tires you're doing, and a failure of a truck tire on the road is very different than a failure on the plane. So those tires are very, very well inspected. It would be very much a shame for the environment and for the consumer if you threw away a perfectly good carcass of a plane tire and didn't retread them. So we are able to operate retreads very, very safely and in a manner that's very environmentally friendly, in fact, for all of us.
I did have another question, but I wanted to mention that the crash of the Concorde many years ago was, in fact, a result, they say, of a piece of metal that was on the runway. You talk about the runway having to be clean. This one in particular wasn't, and the Concorde ran over that piece of metal, burst the tire, and the flying carcass went into the belly of the plane, ruptured the fuel tank, and that caused the aircraft to crash. So very, very profound example of what you're talking about and how the runways have to be clean. You mentioned the environment, and I know we're over, Tom. Hope you don't mind a couple of minutes more.
No problem for me.
Thank you. Thank you. As far as disposal of old tires, we pay a fee here in New York to do that, and I'm wondering what they're doing with them. I've seen the fact that they grind tires up and they use them in roads, they use them in playgrounds, all sorts of places. Are those the best ways to dispose of old tires, or are there better ways that it could be done?
Very good question. First, I want to say that the tire industry is probably the best industry in the world at recouping its own waste. Now, we have a tremendous advantage because people typically go to a tire dealer and they typically pay to have their tires disposed of.
Right.
Unlike that plastic water bottle that some of you are sucking from right now, which you just throw in your garbage. Yeah. Okay. So you're not taking that plastic water bottle to an authorized dealer and having them dispose of it. So we have a tremendous advantage. So what I'm trying to say is I'm trying to be humble and be, it's not that noble. We have a tremendous advantage in being able to control our waste. And we do a good job of it. Now, that being said, how we use it is very difficult. Ground rubber for asphalt is a very good use for playgrounds, a good use, but a minor use. And then another way we use it is for fuel, because most tires are synthetic, made from petroleum. So it's petroleum in a different form. And so we use that for fuel, mainly for concrete kilns, believe it or not. So that's not a bad way of disposing of your tires, of reusing them. So we've done a pretty good job. We've done a very good job of capturing, a pretty good job of reusing. We're always looking for better ways.
Excellent. Excellent. You know, Tom, I want to thank you very much for being a part of this webinar. You've answered a lot of questions. We at AAA in New York have had a long relationship with Michelin. You have been kind enough to do this tire sample that I've been showing here. Every single one of our DIP instructors, our driver improvement program, defensive driving program instructors, has one of these.
Oh, good.
I forget how many you sent to us, but it was a whole lot. And we're very appreciative. It's very useful in explaining tires and wear and how important they are during that part of the class. And I have been on satellite media tours with Sarah Ferguson, and
Right.
one day we did 36 interviews on
Wow.
the Friday of the Labor Day weekend, talking about tires and holiday travel and all those kind of things. And it was always a great pleasure working with her. We've done that, I believe, 3 times. And now we've got you here and talking about tires. So AAA in New York and Michelin go way back. Now you're here with AAA Northeast, as we're part of 5 states now. And I want to thank you very, very much for being a part of this webinar. And I mentioned our defensive driving course, at which your mock-up there is being used, and just wanted to show this to those that are viewing, that they can, let's get the glare off there, go to AAA.com/defensive driving and take that course. You'll learn new laws. You can get points reduction on your license. You can get insurance discounts, and you'll be able to see a sample of a Michelin tire used to illustrate tire wear. And we hope that you will take the course. Tom Carter from Michelin, thank you very much for joining us today. I really appreciate it.
Thank you. And thanks to AAA for all they do for motoring safety. It's quite impressive.
Thank you. Thank you. We're continuing to do the work of COVID notwithstanding, COVID pandemic notwithstanding. Try to use big words, you get into trouble. But we want to thank you all for viewing, tuning in today. We've got other AAA webinars coming up. Go to our website. You'll be able to check them out and register to join them. And thank you so much for what has been a labor of love for me to learn all about tires. And I'll never do a wheel alignment again. New tires. Thank you all. Have a great day.
Unless you have a symptom, Robert.
Unless you have symptoms, that's right. You have to keep it in mind. Rotate those tires, swap those tires, and check them for uneven wear. And we thank you for joining us, and we'll see you again soon. Take care.
Thank you.
So long.